Hi everyone, my name is Yiming and I just finished my final year project at Imperial College London. My project title was Can Deep Learning Go Wrong in Medical Settings? Deep learning has attracted much attention over the last few years. Since it was able to achieve good performance on natural image classification tasks, people believe it can be applied to medical domain as well. But can deep learning go wrong? Are deep learning models as reliable as we thought they are? Sadly, they are not. The phenomenon of adversarial attacks has exposed some potential problems with the current state-of-art deep neural networks. So what are adversarial attacks? They are basically small perturbations on the input to fool the network into giving wrong result with high confidence. Also, there is a parameter epsilon that will decide the level of perturbation. Here is an example of adversarial samples on medical images. The green box at the bottom of each image represent correct predictions, and red boxes, on the other hand, represent wrong predictions. For all pairs of images, the left side is clean and the model was able to classify it correctly. However, after small perturbation that human eyes can't even observe, as shown on the right side of the images, the model messed up the predictions completely. Why do they matter? So adversarial attacks has exposed that models rely on easily perturbed features to make predictions, and these attacks can potentially be carried out to commit fraud against the healthcare systems, which raises safety concerns about deploying models into practice. It is also known that medical images are easier targets than natural images due to their complex biological textures and the nature of CNN models. What can we do to defend against them? So there are two main state-of-art defenses, adversarial training and denoising. In this project, I used adversarial training, which just incorporates both clean and adversarial samples into the training stage. And there's also denoising. The main objectives of this project is to explore how adversarial attacks affect medical images, like what are the effects and what can be the possible reasons, as well as build up a defense using adversarial training, and also explore what are the key components that gives a successful defense. So in the first experiment, I want to see whether adversarial attacks affect medical images, and I find that the standard model's performance dropped a lot while facing adversarial attacks, which showed that adversarial attacks are problematic for medical images. In the next experiment, I experimented on epsilon, which is the level of perturbation and how it affects the model's performance. The results show that in most cases, the higher the epsilon, the more perturbation applied, the worse performance of the model. So I also want to explore what makes adversarial attacks so successful, inspired by another paper where they suggested that non-robust features, which are the features easily perturbed by noises, contributed to adversarial attacks. So by training on only these non-robust features and testing on the original test set, we actually achieved decent result, which showed that the models rely on non-robust features to make predictions. This leaves space for adversarial attacks due to its non-robust characteristics. So in terms of defenses, I first checked whether adversarial training is useful for attacks on medical images, and find out that they do help a lot, as you can see in the graph. The orange bar stands for the performance of adversarially trained models, and they perform way better than the ones trained normally. I also checked the transferability of adversarial training and find out that training on one attack can deal with another attack of the same type, even when the model has not seen the other attack. This is a useful finding since in real life the type of attacks are usually unknown. Then I went on to explore one of the most important parameters of adversarial attacks, which are epsilons. I want to see what are the best epsilons against different level of attacks. Here the results show that the attack epsilon is in a close to linear relationship with the best training epsilon, and their difference is usually less than 0.1. This is a novel finding and can be used to further improve the robustness of the models. And finally, the original paper that suggested adversarial training used 50% adversarial samples in the training set. But is that the optimal value? So I set up an experiment and find out that it seems like 100% adversarial samples in the training set usually gives the best result. This is another novel finding and provided us with another parameter to consider while setting up a successful defense. In conclusion, we've shown that adversarial attacks are problematic for medical images and discovered that the higher the epsilon in attacks, the worse the model performs. In addition, we also demonstrated that the models rely on non-robust features to make predictions. In terms of the defenses, we've shown that adversarial training works for medical images, and there is transferability in adversarial training. In addition, the best performing models' training epsilons are related to the attacking epsilons, with differences usually being below 0.1. And finally, the percentage of adversarial perturbed images in the training set affects the performance of the models, and 100% usually gives the best performance. Of course, there will be some future works that we can work on, including the generalization of models and architectures. In my project, I only used one model and one data set, which can be expanded on, and we also can experiment on different attacks. Maybe it's also worth adding a step of adversarial detection before training, and it also might be interesting to test all my findings under the black box setting, where the attackers can train a surrogate model and use that model to generate adversarial samples that can fool the original model. Thank you for listening, and if you have any questions, feel free to comment below.